Okay, in our second video on transformation, we're going to continue learning about transformation, but now we're going to look at vertical stretching and compression, vertical reflection, and vertical translation or movement up and down. We learned all the horizontal movements last class. So again, we're looking at the standard form of y equals a f of b of x plus c plus d. All right, and to deal with our vertical stretch and compression, we're going to look at the a value. If the absolute value of a is between 0 and 1, then the graph is transformed by a vertical compression by a factor of the absolute value of a. So how does this change? Vertical affects the y values, horizontal affects the x. So today we'll be changing our y values. So the point x comma y is changed to x comma the absolute value of a times y. If the absolute value of a is greater than 1, then the graph is transformed by a vertical stretch by a factor of the absolute value of a. So the point x comma y is transformed to x comma the absolute value of a times y. All right, let's see how that applies into our equation here. We have y is equal to 2 times the cube root of negative x plus 3. This is not in transformation form, so I need to rewrite this as y is equal to 2, the cube root, factor out that negative 1, x minus 3. So that is now in transformation form, and this is what I look at to determine my transformation. So x minus 3 tells me I'm going to go to the right 3, which we learned last class. The 1, since b is 1, the absolute value of b is 1, and it's either greater than 1 nor less than 1, so there's no horizontal stretch or compression. But the negative tells us that we have a reflection across the y-axis. And then the multiplying by the 2, so a is 2 in this problem, tells us that we have a vertical stretch by a factor of 2. Those are the transformations for this problem. So again, our parent function is the cube root of x. So from our parent function, we learn our major point is 0, 0. Key values are 1, 1, and 8. 1, 2, 3, 4, 5, 6, 7, 8, 2. And then negative 1, negative 1, negative 8, negative 2. Okay, so that's our graph. Our first transformation is we're moving to the right 3, and that's going to be x minus 3. And so 1, 2, 3, move that major point to the right 3, and then from that do my key values over 1, up 1, over 8, up 2, back 1, down 1, back 8, down 2. Okay. Next, let me change the color so this doesn't start bleeding into each other. Now we're ready to do our reflection across the y-axis. So that's going to be y is equal to the cube root of that negative x plus 3. And so we're going to do a reflection across. So our previous graph, our main point was at 3, 0. And so reflected across the y-axis, remember we're thinking about if the y-axis is right here. So reflecting across that, we're going to go back 1, up 1, back 8, and now up 2, and then forward 1, down 1, forward 8, down 2, okay. erase that line because that's not part of the graph. That's just to explain what we were doing. And now I'm looking at our vertical stretch by a factor of 2. So looking back here at my red graph, my main point was at 3, 0. And then from that main point, I had gone down 1 and then over 1. And so I'm going to take that y value of 1 and times it by my factor of 2. Yeah, factor of 2. And so that gives us 2. So from that key point here, I need to go down 1 and then over 2. I'm changing the y value because this is a vertical stretch. And then from our next point here, I had gone down 2 and, oops, didn't mean to erase all of that. Okay, I had gone down 2 over 8. So now over 8 down 2. So now I need to go still over 8. So 1, 2, 3, 4, 5, 6, 7, 8. But this time instead of going down 2, I got to take 2 times 2, so down 4. And that gives us this point. 1, 2, 3, 4. Yeah. Oh. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, you're missing the point there. Unfortunately, I'm not drawing it very well. Okay, so now I need to go back 1. Oh, that's the reason why I have that point off. Let's try this whole graph again. All right, so key value is 3, 0. I should go over 1, down 2, back 1, up 2, over 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 4 to get this curve. That's looking better. And then 1, 2, 3, 4, 5, 6, 7, 8, and then up 4. Okay. So I changed the height, the y. And that gives us our final graph, which is y is equal to 2 the cube root of negative x plus 3. What is our domain? All real numbers. And what is our range? Also all real numbers. Our last type of transformation we're going to learn is a vertical, or next to last, sorry, is vertical reflection. And this is also determined by the A. And it's written in this transformation form. I was also looking at the A. If A is less than 0, if A is negative, then the graph is horizontally reflected about the x-axis. So the coordinates change from x comma y to x comma negative y. Again, horizontal is changing. Well, that should not be horizontal, it's vertical. Because vertical is changing the y values. Horizontal changes the x values. Okay. So, identify the transformation of this graph. Well, our parent function is our quadratic function. And it's already in transformation form, so x plus 3, the plus 3 tells us to move to the left 3 units. And then A is outside the square operation, so that's negative 1, so that is a reflection across the x-axis is that transformation. So those are the only transformations we have. So we start by graphing our original function, y equals x squared, main point, key values, okay, now I'm going to deal with this plus 3. So y is equal to x plus 3 quantity squared. And that's left 3. So 1, 2, 3. Move that midpoint less 3. And then do my key values from that. Over 1, up 1. Over 2, up 4. Back 1, up 1. Negative 2, positive 4. Okay. And now change colors again. We have y is equal to negative parentheses x plus 3 quantity squared. So I take my yellow graph, which was the main value here was at negative 3 comma 0. And I'm going to reflect across this x-axis because the main point is still on that x-axis. And so I had gone over 1 up 1, so now I'm going to go over 1 down 1, over 2 down 4. Back 1, down 1, back 2, down 4. And that is the graph of my function. My domain is all real numbers, but the range, on the other hand, is from negative infinity to 0, including the 0. Now we're to the last transformation. Okay, we're going to do vertical translation. This deals with the d when it's written in that transformation form of y equals a of f of b of x plus c plus d. Okay, so again, we are now looking at this term. Will tell us if we're moving up or down. If the d value is greater than 0, then we translate a vertical translation up d units. So x comma y becomes the point x comma y plus d. If d is less than 0, we translate a vertical unit down d units. So the point x comma y is still the point x comma y plus d, but I'll be adding a negative value, so it's like subtracting d. All right, so we're going to do vertical translations of this. So we're going to do our cubic function as our parent function here. It's already in transformation form. The x plus 2, I'll do this in green, tells us that we go to the left 2. And then the plus 1 tells us that we go up 1. That's our only transformation for this problem. So our parent function is the cubic graph. So main point is at 0, 0, 1, 1, 2, 8, negative 1, 1, negative 2, 8. That's y equals x cubed. All right, now we're going to move this graph to the left 2. So 1, 2, move that main point to the left 2, and then do my key values over 1, up 1, over 2, up 8 from that main point, back 1, down 1, back 2, down 8. That looks too straight. Notice how it kind of straightened up. So I'm going to redraw that so that you can see that there's a curve there, and that's how I want you to draw it. And that is y is equal to x plus 2 quantity cubed. Okay, now we're going to deal with the up 1. So if that main point from our last graph was at negative 2, 0, I'm going to take that main point and move it up 1. And then from that, I'm going to do my key values. Over 1, 1, 1, 2, 8, negative 1, 1, negative 2, down 8. And that is the graph of y equals x plus 2 quantity cubed plus 1. Our domain is all real numbers. Our range is also all real numbers. Let's do one more. We haven't done a rational function yet, so let's do a rational function. All right, so we're going to graph this. It's already in transformation form. So let's see. Let's start. This plus 3 here inside the function tells me that I'm moving to the right 3. And then minus here tells us outside of the 1 over x, which is our parent function, tells us that we have reflection across x-axis. And then this plus, whoops, try that again. This plus 4 here tells us we move up 4 units. So there's our transformations here. So starting with my parent function of the rational function. So remember the rational function you have, let me do a better color so it shows up a little bit. So we have asymptotes on the x-axis, asymptotes on the y-axis. Our main point is where those asymptotes intersect with 0, 0. From the intersection of asymptotes, we go up 1 over 1, and then over 2 up a half, over a half up 2 to get that first curve. And we do the same thing with the negative. Back 1, down 1, back 2, down a half, back a half, down 2. And that gives us our curve of y equals 1 over x, our parent function. All right. So we're going to take that main point, which is the intersection of the vertical and horizontal asymptote, and move it to the right 3. So 1, 2, 3. And so now that's where our vertical and horizontal asymptotes go. And then we're going to plot our points from that main point. We go over 1, up 1, over 2, up a half, over a half, up 2. Back 1, down 1, back 2, down a half, back a half, down 2. And that gives us y is equal to 1 over x minus 3. Now we're going to deal with the green, which is our reflection across the x-axis. So again, our main point is the intersection of those two asymptotes. Let me draw those asymptotes again. So our main point is here. Now we're not going to keep that main point on there because, again, that's not part of the graph, but that's what we're looking at as our main point. And we're going to reflect across the x-axis, so that that horizontal asymptote there. And so from our orange graph, we normally go over 1, up 1. So now I want to go over 1, but down 1 to reflect that curve. Over 2, down a half. Over a half, down 2. So that's the reflection of that first part of the graph across the x-axis. Now, the bottom part of the graph, I'm now going to reflect across the x-axis. So from that major point, I'm going to go over 1, up 1, over 2, up a half, over a half, up 2. And that gives us our graph of y equals negative 1 over x minus 3. And then our last thing that we got to do is we got to move up 4. So that's our main point because we're moving up and down. So over 3 up 4 now means I have my horizontal asymptote going through 4 and my vertical asymptote is going through 3. And again, that point where that's our main point where those intersect, but that's not actually a point on our graph. So let me erase it really fast. Okay, and then I'm just going to plot from that. I'm going to go down 1, over 1, down 1, over 2, down a half, over a half, down 2, over 1, up 1, over 2, up a half, over 2, over a half, up 2. And that gives us our final graph. Okay. So notice our domain here is all x values except where that horizontal, except where that vertical asymptote is at, which is at 3. So that's negative infinity to 3, union 3 to infinity. And our range is all all y values except where that horizontal asymptote intersects the y-axis. So that's from negative infinity to 4, union 4 to infinity. All right, so that is how you do transformations. We now learned all of the different transformations. I'm going to practice these and start putting them together in class. So make sure you study over this.